Okay, so we're on page 26, revisiting equations of tangent lines. But first we'll do an interpretation exercise. The amount of Arctic sea ice can be modeled by a differentiable function a of t. Okay, so we know we've got a derivative sequence going on, where a of t is measured in millions of square kilometers. Okay, so a is representing like a certain amount of something, and so a prime will be its rate of change. And so we know there's at least an a prime. There's at least a rate of change of whatever a is, and possibly even an a double prime. All right, so we'll set this up. And so this, let me put the units in. So this is the millions of square kilometers. This is millions. Okay. All right, selected values are shown in the table below. So interpret a of 83 in the above context, and then we will approximate a prime of 90 and then interpret our answer in context. Okay, so a of 83. So this is part A. A of 83, it's right here, equals 14.4, and the units are million square kilometers. Okay, so the interpretation, I'm going to try to just go for it, guys, but you could still be using, I'll put these here in case you want to write them down and think it through by thinking very generally what these things mean and then piecing it together. But, okay, so a of 83. So let me think about this. So at t equals 83, so I know year 0 is 2023. Year 1 would be 2024. Year 2 would be 2025. So I've got to add 83. Whoa, 2023. So this is like a prediction. Oh, shoot. 2023 plus 83. Okay, so 2106. In the year, so I'll say on 1/1/26, the amount of Arctic sea ice will be 14.4 million square kilometers, or kilometers square. Okay, good. All right, now for part B, we're going to be estimating, we're going to have to do AROC, but we're going to be estimating IROC, which is if you have A and you want its instantaneous rate of change, that means that you're thinking about the derivative. So a prime of 90, so we're only going to be able to estimate it, and 90 falls, so find an interval. Try to find this number 90 in the table, and then if it's not in the table, find an interval, the smallest interval you can that it is within. So it is within this interval here. So the best we can do is use the AROC on this interval to approximate the IROC at 90. Okay, so A prime of 90 is approximately 14.1 minus 14.4, so negative 0.3 over 97 minus 83, so 10. All right, you can actually do this like without a calculator, but try to for sure. Divided by, wait, what am I doing? 97, my bad, sorry. 97 minus 83, 14. Yeah. Yikes. Okay, so negative 0.3 divided by 4. Alrighty, so I'm getting negative 0.02. We always want 3 decimal places. 021. And the units here are million kilometers squared per year. Oh, finally we've got an interpretation of a rate where it's negative. Okay, so I'll write it up here. So now 90 years from the start is 2023 plus 90 is 2113. Okay, I'll write it up here. On one, wait a minute, I said 26. What was I doing? What? 2106. On 1-1, this should be 2106. Maybe that's how you should write it. I'm not thinking that far ahead. Okay, so if you added 90, okay, so on January 1st, 2113, the amount of Arctic sea ice is decreasing. You could say melting instead of decreasing, but is decreasing at a rate of approximately 0.021 million square kilometers per year. Okay, guys, all right, let's move on. So find an equation of the tangent line to the curve y equals x radical x that is parallel to the line y equals 1 plus 3x. So guys, at this point, let's get out a graphing calculator and let's graph this situation. Okay, so I go to y equals, oh, and guys, for a later problem, we need to be in radians. So in AP Calc, you're always in radians. Okay, so here, darn it, I want that to be, all right, so x, and then square root of x. So x squared of x. And now, all right, so that's my function, and I'm trying to find the tangent line, the equation of the tangent line to the graph of this, and I want that tangent line to be parallel to another graph, which is a line, 1 plus 3x. And zoom 6 will give you like, go from negative 10 to 10. All right, let me get a better picture. So it looks like the action I'm looking for is like in the first quadrant, which makes sense because you can't have negative x's for this blue graph. So let me go to my window, and I'll have like my leftmost x, x min, I'll do like negative 2. Rightmost max, I don't know, maybe I'll do 50. And then our lowest y, let's have the negative 2, and then our highest y, I'll also do 50. Let's see what that looks like. Alrighty. Okay, so we are looking for, oh, actually, let's zoom in even more. So what we're looking for is a point that is on this blue graph that is parallel, or that has a tangent line that's parallel to the red graph. So let's do another thing. So let's go zoom box. This is really nice. It helps you to control the window. So guys, you should be doing this with me, and maybe even like going ahead of me or trying things on the calculator. All right, so if we go like this, and then I hit enter, okay, so that's very nice. So I gotta find a point that is on this blue graph that is parallel to that line. And I don't know, I'm imagining the tangents, I don't know, maybe like about here? We'll see, but I want the equation of it. So once we find the equation of it, go ahead of me if you've got this. We will graph it also in here and see if it looks parallel, if it looks like we did it. All right, anytime you're gonna find the equation of a tangent line, you need 3 ingredients, x1, y1, and m tan, and then you could use the y minus y1 formula. Okay, so do we know any of these things? No. But actually we kind of do, because parallel lines have equal slopes. So the slope of this, so the slope of that is 3. The slope of a line, y equals mx plus b, so the slope is 3. So if our tangent line is parallel to this line, then m tan, that's the slope of the tangent line, needs to be 3 as well. So we actually do know something. We know that. Okay, so guys, what is m tan? M tan is the derivative. The derivative of what? Of this, in this case. So if we find the derivative of this, then we can, that is m tan, but we want to figure out the moment when m tan is 3. So we're going to take the derivative, we're going to set it equal to 3. That's going to get us x1. And I'll let you think about y1. All right, so let's get x1. So, oh yeah, all right. All right. So anyway, guys, this is not a one-step derivative. It's the product of 2 one-steps, but it in and of itself is not. But you can rewrite it. This is y equals x to the 3/2. Okay, so that is still y. That is not the derivative yet. And now it's a one-step. X to the 1/2. Okay, so we're about to do algebra, so it would be nice if I had y prime in that form. Alrighty, so 3 radical x over 2 equals 3. So we're going to solve for x. So okay, so x1 is 4. And then guys, y1 is f of 4. And m tan, by the way, is f prime of 4. That's usually how we like set it up. So what is f? F is the same as y in this context. So for f of 4, I'm just plugging 4 into here. And I get, actually 4, wait, I get 8. Because 4, and then square root of 4. Okay, so now that you have those 3 numbers, y minus y1 equals m tan x minus x1. Okay, now you don't have to, as your answer, guys, you don't have to add the 8 over, but we're going to have to add the 8 over in our calculator. All right, so let's check this and see if it looks right. So go to y equals, all right, so I'm going to have 3 x minus 4 and then add 8 at the end. Oh, perfect. That looks perfect. Okay, so there's that. Okay, maybe I should stop the video here, and then we could do this one in class together. Or you could try to go ahead of me, try to do it. Because we've done it before. And yeah, see if you could do that on your own, guys. That'd be wonderful. So try to do this on your own. At least read it. And then if you can't do it, you're not even sure how to start, I'll do it in class.